G'day guys, for my next trick I'm going to make it so I can actually change my terrain. I can delete stuff, move stuff around and add them back. I might have to add some lighting after this because I'm realizing it's a bit hard to see what I'm doing now. But we're going to make it so we can click and delete and click and add. And the first thing we need to do before we can do that is actually add colliders, which we've skipped so far, so that we can click on stuff. So let's get on to adding colliders. All right, so the very first thing I'm going to actually do is rearrange things a little bit. I'm going to make a new scene, and I'm just going to call this root the GM. And what we'll do is we'll build everything based off of that. So we'll drop the world on there. And so the GM is going to do other stuff. The world is going to be like our terrain, and all the chunks are going to be attached to that. And the reason I need that right now is because I need somewhere to put my camera. I can't attach it to the world because that regularly gets all its children deleted. So what we're going to do now is add a camera. So let's do that. Camera 3D. And we're going to need this now because once we start playing with physics, I don't really want to do it in the editor anymore. We'll do it in the actual game. So we'll need the camera working. So let us make a camera script. I'm going to call it free look cam. And I'm going to rush through this quite a bit because I'm just grabbing this from somewhere else. I've got a camera that I reuse all the time. So we've just got all our camera sensitivity, speed, all that kind of stuff. Camera positions. And I'll just drop these into the process. We've got first we're going to get all the inputs, and then we're going to apply the movement. Forgot to add velocity. All right, now I just need to add all these inputs. So we've just got cam left, cam right, up, cam down, cam back, cam forward. I'm going to have a cam speed multiplier. We're going to hold down to make it move really quick. I'm going to have a button to toggle the mouse look. So cam toggle mouse look. And I'm going to add a click in here, but that's for later. And while we're here, let's also add our button to add a block. And so we're just going to go for cam left, A. Cam right, D. So we're just doing WASDF. For up, we're going to do spacebar. For down, I'll use control. Back is going to be S. Forward, W. I'm going to hold down shift. That'll make the camera move quicker. To toggle mouse look, we're going to right mouse button. My click is just going to be a left click. And to add block, the way I'm going to set it up is so a left click will delete a block. And if we hold down F, it will add a block. Yeah, that's good enough for now. So now I think that should just work. Let's give that a quick try. Oh, I think I need to put something in my world so I know it's moving around. I'll tell you what I'll do. Let's just go print position and rotation so we can know that the camera's there and it's moving. And it is not. Let's just do a quick reload current project. That usually fixes a weird crap like this. So I've got the camera's definitely here, but it's not moving. Let's go print cam left. Let's make sure that actual button is being seen. It is. Okay, so my rotating is work. When I right click, it's rotating. I can see the rotation numbers there changing, but I'm not panning for some reason. So we've got the velocity. Let's just check here at the end of get inputs. Let's just go print velocity and make sure everything's changing. So yeah, the velocity is changing, but it's not being added to my position. Let's go and put our actual world in. So I'll actually just tell my world as soon as it starts to generate chunks equals true. And we'll just make sure it's only doing 4 by 4 by 2, so we don't have to load too much, all right? So we can see the world's loaded. We're not moving. Let's just try taking the camera and moving it up quite high. So my camera's up here, but my WASDF is not applying movement. Let's just change the camera speed a little bit. Oh, okay, so it's just a problem with the default speed. Right, so you see I've got my normal speed moving around. If I hold down shift, it's way quicker. Be a little bit too quick. Let's just change that back to 5 times. Let's make it default 15, and when we hold down shift, it will go 5 times faster. All right, so yeah, that's pretty fast. Too fast for in-game, but good for screwing around and playing. All right, so now we can roll around. That's a good start. That'll make it easier for doing some testing. All right, so let's just get rid of those little prints I put in there. All right, now making a chunk have a collider is not that hard. What we've got to do is grab our chunk. So what you would usually do is, since this doesn't move, it would be, you'd have a static body 3D. This mesh would be a child of that, as would the collider mesh. I don't want to fiddle with my hierarchy so much yet. So what I'm going to do is just add to this my static body as a child, and then as a child, as a child of that, we're going to add our collision shape 3D. So that's just going to be part of it now. And what we'll do is when we generate our mesh, we'll pass it through to the collision shape 3D. So there's nothing else to do here except for save it. And then in our chunk, what we'll do is it will generate all this mesh stuff. And then what we do is after we've made the mesh, just go var try mesh collisions equals a mesh dot create tri-mesh shape. So that will, from our mesh, make the tri-mesh shape, and we'll go collision shape 3D equals, oops, and we'll say that's a collision shape 3D. And that equals, and we'll just find child, and the child we're going to find is that static body 3D. So static body 3D, and then from it, we're going to grab its child, the collision shape 3D. And so that's our collision shape 3D. And then we're going to grab that guy and just go set shape tri-mesh collisions. So basically we've just here made the tri-mesh collisions and pass it through to that collision shape 3D, pass it through to here. And that should do it. So what we'll do now is we will go back to our world. Let's go back to our GM world. And you'll see, I believe that is the actual colliders. Now, if I run it, it doesn't really tell us much. So let's drop in a ball and see if it bounces properly. And what I'll do is with this camera, let's rotate that so it starts in the correct direction. All right, so let's just add a ball. So we're going to add a rigid body 3D. To that, we're going to add a mesh. And the mesh is going to be a sphere mesh. And then we'll also add a collider for that. Collision shape 3D. And so for this one, it will get that sphere shape 3D. So now we've got a little ball. And we'll just put that in front of us, and we should be able to see that fall down and hopefully bounce off here. I think that's about right. All right, let's give that a try. And there we go. All right, let's just try a few things out. Let's move him a little bit. I just really want to have him bounce off one of these corners to make sure he rolls down the stairs properly. All right, I'll move him a little bit to the left. Of course, I could be putting in like some script so we can shoot these guys out or something and do some more playing, but I really just need to make sure this works. There we go. So you can see we are actually bouncing off the steps, rolling around. Yep, that's all the physics we need. So now we've got physics working on this. Now we need to make it so we can click and stuff will happen. And so for that, we're actually going to do a raycast. And what will happen is basically when you click on a screen, it finds that point of the screen, projects it from the camera. So basically imagine this is your screen here. It will project a line out until it hits a collider. So if I click here, it will shoot a line out from the screen until it hits here and will tell me that point. It should tell me what it's hit as well and give me a bunch of useful information. So that we're going to add to our camera script. And so you may have noticed I already had that here. It's a really common thing to use. I just commented it out. So raycast from the mouse position. And this is actually not a small bit of code for Godot. It's a bit hefty actually. It's a lot simpler in lots of other engines. But so what we do is first it grabs the mouse position on the screen. And then I tell it how far I want it to shoot. I could probably make this longer in the end if I needed to, like if I'm clicking on the other side of the map. So the from position is sort of that it goes and finds the 3D position of the mouse in the world. And then we're going to shoot one out from the screen in the world space. And this is the query. So this is the actual thing that does it. It actually does the raycast from here to here, and then I grab a result. And the result is what I want. That gives me all the information. So let's just go print raycast result, and let's see what we get. So when I left click, you can see we get a position. That's the world position. We get the normal, and the normal is important because what the normal is that tells me this face here, which direction is it facing. So this one is facing up. So you can see the normal is 1 on the y-axis. And if I click this one, it's going out this way, which will be 1 on the x or y axis, on the z, sorry, on the x or z axis. So this actually tells us the face we're clicking, which direction is it? And this is good because when I click here, this is sort of, the spot I'm clicking is sort of between. It's between this empty square and this filled one. So what I'm going to do is I'm going to use the normal to decide, all right, if I want to delete a block, I'm actually going to go this way a little bit, so the opposite of the normal direction. And if I want to add a block, I'm going to find this position by going outways on that normal direction. So normal is really important. Otherwise, when I click, it's sort of going to be a toss-up whether we get this one or this one. Everything else I don't really need. It's just the colliders. So this one, the static body 3D, that's actually the chunk. So I can talk to the chunk if I want to, but I'm not going to do that. When I click something, I'm going to talk to the world, and then it'll grab the position. And if I'm adding a block, it will then talk to the chunk. So I'm going to do all that stuff through the sort of high level of the world. So let's do that. So the first thing I'm going to do is the raycast result. As you can see, it's like a dictionary. So let's just go if the len of raycast result is greater than 0, then we're going to find that hit position. So it's raycast result dot position. And what I'm going to do to make sure I'm grabbing the inside of the block, instead of that edge, I'm just going to go minus raycast result dot normal times 0.5. And 0.5 because, oops, let me show you. So if I click here and I did the normal, it would put me exactly here between these two cubes. So we go back by half of the normal. So that'll put me not exactly in the middle, because if I click here, it's going to go back from there. We could do something to make it find the middle. In fact, we will. We'll round it to find the middle. So basically, it'll round it. We'll go back, and that's how we'll make sure we get that exact cube. And so let's round that now. So let's go hit pause equals, and I'll just change this to a vector 3i. which that may hurt some people's feelings, but let's round it. The hit pos.x, and we'll just do the same with everything. And just round it to the nearest. All right, so now, because when I click, by default, it's going to delete a block, or if I hold down F, it's going to add a block. Let's add that now. So if input.is action pressed, and it was add block. So if we're holding the add block button, we will change the hit position a little bit. We'll actually add the raycast result normal to it. And so what that would do, if I clicked here and it's gone to the middle of here, it'll actually go whoop and bring it back out to the one adjacent from it. If I clicked here, by default, it would grab the middle of this block, but if I'm holding down F, it will go up by 1. So that's my little trick. All right, now here's where we actually make a change. We're going to go to the world and just go set block, and we'll specify by world position. Because for the chunks, they're all going to deal with just local positions, but the world is going to use the world positions. But I'm going to write it in just to be sure. So I always confuse myself with stuff like this. And we'll say block type .dirt. So if I'm adding, we'll do that. If I'm not holding that, we won't do the extra addition of the normal. We would just go block type air. So there's no such thing as a world yet. We don't know what that is. So let's add that. So to find the world, we're just going to go on ready var world equal what is that equals, let's see, it's $, ... world. So that will grab me the dot will give me the GM, and world will give me that. And so now, oh, did I spell block type wrong? Yep, I put a capital L there. All right, so now for the world, I don't think I've made a set block by world position yet, so let's do that. So we've got get block. And so we've got the position, which is a vector 3i, and the block type, which is a block.block type. Okay, now the trick here is going to be that I first have to find the chunk. And the chunks are set in a dictionary, each one stored keyed to its position. And the position is based on the chunk size. So the first one would be 0, 0, 0. The second one would be, my chunk size is 16, so it's going to be 16, 0, 0. So what we need to do is basically take this position, the world position, and basically round it down to the nearest 16, to the nearest chunk size. So we do it like this. Chunk pos, and let's make a function for this because we're going to do it. So let's go world pos to chunk pos, and let's make that func. And this is going to be a bit tricky. All we do is we go return our pos divided by the chunk size, and then multiplied by the chunk size. And that's just a bit of integer maths, because what happens is when I divide it by the chunk size, that will basically, if it's 16, it'll go down to 0. If it's 17, it'll go down to, am I saying that right? If it's anything from 0 to 15, it will be rounded down to 0, because it's just integer maths. There's no decimal places. But if we're 16, it'll be 1. If we're 32, it'll be 2. And then what we do is we just take that integer we've got, if it's a 0 or 1 or 2, and we multiply it by the chunk size. So that will basically cut off all the remainder and just give us, if we're on number, let's say 23, it will basically round that down to the nearest 16. You're all programmers, you should know your integer maths, and it works for the vector 3i as well. I have checked. All right, so we've got the world position now. Basically, we've got the chunk position, and now we need to get the actual local position inside that chunk that we'll pass to the chunk. So var local pos, and what I'm saying now is, let's say it was number 26. We're going to cut anything past 16 off, And the local position is going to be sort of 26 minus 16. So 16 is the chunk position, and what's that going to be? Is 10 is going to be the local position. Hopefully that made sense. I didn't ramble it too much. So it's just going to be pos minus chunk pos, simple as that. So then we're going to just make sure we actually have that chunk. So if we has that chunk in our chunks dictionary, we go chunks, chunk pos dot set block, and we'll pass that through the local position, and we'll pass it through the block type. And the other thing we've got to do is just regenerate that mesh then. Was it gen chunk? I better check it. Gen chunk, yeah. All right, so let's go make a set block work. I don't think I've got a set block yet. All right, so all the blocks are initialized here and nothing happens to them after that. So let's go func set block, and it's going to have the local position. It's going to have the block type. And what we do now is we basically just do this one. Blocks number X, Y, Z equals block type. Oh, sorry. Local pos dot X, local pos dot Y, local pos dot Z. So that's set block. Is this going to just work? Let's give it a go. All right, so we click here and bam, it disappeared. Click here, it disappears. If I hold down F, we add it back. If I click it here, we add it back. So you can see it is working. Now, this is not finished yet because we're going to have some bugs with this. When I click, 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 when we reach, you can see when we reach the, when we reach the edge between two chunks, it doesn't quite know what to do then. So you can see once I'm inside the other chunk, it's fine. So there's two main problems here. The big one is when I click this one here, so this is a separate chunk, it's checking this block over here and it still thinks it's dirt. And so it doesn't do anything there. So this guy, when it's checking the neighboring blocks, it's actually asking the world, hey, what's at this block? And when you ask the world, it gives you the, basically it just generates it from the noise seed. So what we need to do is make sure at the start, when we first generate everything, it will use the noise. But then from then on, if ever a block is looking at itself, it already will look at what's already there. But when it asks what's next door, we need the world to grab the actual chunk and say, hey, chunk, what's at this block? So this one will say, hey, world, what's here? And the chunk will tell it. So let's do that. And we'll also have to make it so when we edit this block, it will actually update the surrounding chunks as well. When we're on an edge, we need to update this chunk as well. If I'm clicking in here, it's only one chunk, but if we click on the edge, we have to update the surrounding blocks as well, the surrounding chunks, I should say. So let's do that. So what we'll do is right now we're just setting the single block, and we need to check basically, are we adjacent? And so we'll make a little function. Block is on edge of chunk. We'll give it a position. And it could actually be on the edge of more than one other chunk. So we need to make it return a list. So let's go edges. And basically, we're going to use a local position for this. So it's if pos.x equals 0, then we'll go edges.append. And what we'll do is we'll basically give it like a normal. We'll give it a vector 3i. And if it's on 0, it means we need to go -1 to the x. And so I'll treat this is sort of how you do a vector. This is how you do a direction. And then when we're grabbing the actual next door chunk, we'll just multiply that by the chunk size. And then we'll go if pos.y equals 0, basically the same thing, but for y, it won't be on the x, it'll be -1 on the y. If it's z, we go -1 on the Z, and then we've got if pos.x is greater than or equal to the chunk size -1, then we'll add 1 to that. So this is going to return a list of these vector3 directions. So it's 1 and 1. Return edges. And so when we ask this one, when we give it a local position, it will say if it's 0, grab the one to the left. If it's a 16, sorry, if it's a 15, we grab the one to the right, because if it's 16, it will already be the next door one. All right, so here's what we do. We just go adjacent chunks equals block is on edge of chunk, local pos, and then we go for adjacent chunk in adjacent chunks, and we'll get that adjacent chunk position. Adjacent chunk pos equals the adjacent chunk. So this one we're looking at right now, the one out of the list. Sorry, we have to go to the chunk pos, so grab the current chunk pos, and then we're going to add to that the direction multiplied by the chunk size. So let's say the chunk position was 16, 16, 16, and we're grabbing the one to the left of it. That will be x minus 1 times 16, so it'll minus 16 from that. So it'll be now 0, 16, 16, if that makes sense. All right, and then we just go if chunks, basically the same thing here. If chunks has adjacent chunk position. Now we're not changing any block, we just need to tell that chunk to regenerate, and then it'll go and ask its neighbors, which we'll fix in a minute. And I'm going to change this a little bit because right now we're changing it to directly change. And if I'm doing like 3 others, we're going to tell 3 others to change at the same time. And another big problem is going to be if I've got like 3 or 4, if I'm right now I'm changing 1 block at a time. If I'm changing like 20 blocks, chunks will get regenerated 2 or 3 times in one go. So what we're going to do is we're not going to say generate chunk. What we're going to do is we're going to make a list. Chunks tagged for regen as a list. And what we'll do is at the end of every tick, we'll just go for chunk in chunks tagged for regen, and then we'll go chunk dot gen chunk, and then chunks tagged for regen, we will clear it. So then no matter how many times we change one chunk, it will only get regenerated once. So for this one, what we will do now is we will not do that directly. We'll go chunks tagged for regen dot append that chunk. And same thing for this one, we'll just add it to the list. So now what we've got to do is this get block function, right now it just returns based on the noise. And we only want to do that once. So what we might do, let's add a Boolean to it from noise. So if I'm true on from noise, we will grab it from here. We'll just generate it directly. And if not, we will actually ask the chunk. So what we'll do is go if not from noise, we'll do it this way and then return at the end. And otherwise we'll go through and do it this way. And to get a block, we'll just use our little trick here. We'll be going get block instead. Okay, so I don't actually have to have that there. So if we've actually got it, we can go chunks, chunk pos, get block from that local position. Oh, that's throwing an error because we're a tool here. Let's just do a quick reload of the current project. Okay, so now we just have to set up this get block. Chunk, so go to my chunk. And do we have a set block? We'll put it next to that. And we'll just return this. And what I'm going to do is just add a little variable here. First load equals true. So when it first loads, it will go and get its blocks. So here we're getting the block from the world, and we just need to add that first load to it. And I'm not sure I can do this. Let's make this by default equal false. I'm not 100% sure this works in Godot. I'll have to check. So what that should mean is if we just send it a position, it will basically do it not from noise. And only if we put a true in there, will it do this. And that'll save me changing all the existing instances. One more thing we need to do is to make sure after we've initially generated it, we're going to go first load equals false. So basically, once we've initially gotten it all from the noise, it should in the future, whenever we say get block, get it from the actual chunks that exist already. All right, let's go back to world. Let's just have a quick look at get block in world. All right, let's see if that works. Hold on, let me make this screen a bit bigger. (1920 by 1080). All right. All right, so it's working. And as I'm clicking, we're not seeing any missing faces. I think that's worked. Adding some back. Now that's interesting. I'm not sure why that's gone like that. Let's take one moment. I do want to, on the edges, actually make those blocked out. So we are going to have like a camera moving around. I don't want the users to see this and be able to do things like that. So we'll make it so when we're on the edge of the map, we'll treat that as air. And so what we'll just do in get block, we'll say no matter what, if pos.x is less than 0, or pos.y is less than 0, or pos.z is less than 0, or pos.x is greater than equal to world size.x multiplied by chunk size. Is that right? I think so. All right, let's put in all the y and z. Then we'll just say return block.blocktype.air. And then my edges should always be dirt. And it will just look a bit nicer. Yeah, that looks much nicer. And I'll just try it from the other side. And looks like it's working to me. At no point am I seeing anything that's not working how it should work. Let's have a look underneath. Yeah, so I can build stuff in there. Yeah, so I think this is all working quite nice. Underneath, yep. Now I wonder what happens if I just build a huge tower. It gets as high as it can, and we just can't go anymore. That's working really well. Now, if I wanted to be able to go further up, all I would do is when I create my world, I add more Y chunks. If I wanted to go further down, that's a little bit trickier to add. I could make it so it also creates -1s as well. But yeah, I think we've got a nice little voxel system working now. I'm not sure exactly what I'll do next. I might go back to what I did next when I was doing 2D and add the pathfinding and have my little guys walking around. But I think I don't want guys to be able to walk up blocks like that. So we might have to put in little ramps. So we might not be finished with the voxel system itself yet. And we might do lighting because this is pretty ugly and hard to look at when you've got sort of bits like that. So I'll have a fiddle with that. Anyway, we probably are going over time now. So thanks a lot for your time, guys. I'll let you go. See you later.